All right, good morning. Today we're going to do another flipped classroom. Pretty excited about that. I know you guys enjoy it, so I thought this would be a great opportunity to do it. Today we're going to do 4.3 multiplication with decimals and whole numbers. You're on page 245 to start this morning. Okay. So today is just an extension of what we learned the other day. Yesterday we learned how to model those numbers. Today we're going to learn how to do the math part of it. Okay, so by the end of this lesson, you should know not only how to draw maybe a quick picture or shade in 100 squares, but now you'll be able to do the true math, the quick, more efficient way to do it. Okay, so let's just dive right in. I'm gonna read. You guys are gonna underline and circle important information. Okay, all right, here we go. In 2010, the United States Mint released a newly designed Lincoln penny. A Lincoln penny has a mass of 2.5 grams. If there are 5 Lincoln pennies on a tray, what is the total mass of the pennies? Okay, so the first thing it wants us to do is to try to estimate so that we have an idea of where we need to be when we answer our question. Okay, so when we estimate this, we're going to estimate. We don't need to round 5. 5's a nice number, but we're always going to round that decimal. We're always going to estimate that decimal to the nearest whole number. So if we look at 2 and we ask our neighbor 5, 5 tells us to round up. Okay, 5 and above, give it a shove. So we're going to round 5. We're going to round that 2, I'm sorry, up to 3. Okay, and 5 times 3 is 15. So our answer is going to be really close to 15, all right? If it's way off, then we know we kind of need to start over, all right? So one way to solve this problem is by using the distributive property. We learned this back in chapter 1. We learned about the distributive property and the associative property and the commutative property, okay? Today we're going to use the distributive property. And the distributive property means we break up our number that's kind of ugly, and then we multiply each of those numbers by the other multiplying number. Okay, so we're going to break up 2.5. All right, and if you break up 2.5, you're going to break it up into 2 wholes plus 5 tenths or a half. Okay, and then we know we need to multiply each of those numbers by the other number being multiplied, which is 5. So we're going 5 times 2 and 5 times 5 or a half. Okay, so we know 5 times 2 is 10, all right, and 5 times a half is 5 times 5 is 25. That's 2 wholes and 5 tenths, so it's 2.5 or 2 and 5 tenths. And 10 plus 2 and 5 tenths is 12 and 5 tenths. Okay, so that's one way to do the distributive property. It is not my favorite, but if you see that right there, boom, use it. It's a great tool. Break it up, multiply it. But a lot of you are going to want to probably do the partial products way just because it looks more familiar. Okay, so we're going to get this erased. All right, and let's get scrolled down here a way so we can kind of work on this. Okay. So we're going to multiply the tenths first. We're going to do the exact same thing, man. We're going to start right to left. So as you can see, our blue numbers are highlighted here. We're going to go small number to small number. Okay, so we're going to go 5 times 5. So if we did 5 wholes times 5 tenths, so 5 times 5 tenths, you're going to get 25 tenths. But we know after every 10 tenths, that equals a whole. So if we broke up or renamed, which you guys learned about yesterday, 25 tenths, you're going to get 2 wholes with 5 tenths left over. Okay, so here, let me show you how this works. We know 5 times 5 is 25. But we also know 25 tenths breaks up into 2 whole numbers, which is 2 groups of 10, and 5 tenths left over. So you're going to get 2 and half, or 2 and 5 tenths. Okay? Then we move on, just like we do in a normal math problem, we move on to the next place value. So we go 5 wholes times 2 wholes. And anytime we multiply whole numbers, we want to make sure we keep them in the correct place value. So remember, we always we're not going to work under that 5. We're going to stay over in the whole numbers. And so 5 times 10, or 5 times 2 is 10. Notice where my 0 is. Notice my 0 is not underneath the 5 because it is not a decimal or a fraction. It is 5 wholes times 2 wholes. So it needs to be left of that decimal point. You've got to make sure you line these numbers up correctly. Okay? So that's one thing you got to watch for. That's the one thing that might slip up. Okay? So let me move you here. We'll scroll on down one more time here. And look how it's set up. It's set up nice and neat for you. You got 2.5, which is 5 times 5, okay? And 5 times 2 is 10 wholes, and so we stayed to the left of the decimal. All right? So then you just do the third process in 2-digit multiplication, and you just add them up. Okay? I'm going to pretend like I got a little 0 here. So 5 times 0 is, or 5 plus, I'm sorry, 0 is 5. Don't forget your decimal. Okay? 2 plus 0 is 2, and 1 plus 0 is 1. So either way you do it, you're going to get 12.5 grams, or 12 and 5/10 grams. Okay? So you got 2 ways you can model this, okay? Today, well, not model, but 2 ways to solve. We don't want to model today. We want to do the mathematical way, okay? So you can use the distributive property, all right, which breaks up our 2-digit number, or if it's a 3-digit or whatever it end up might be, you're going to break up that number and then multiply it by each of the breakups by, or each of the place values, if you will, by 5 and then add them up. Or you can come use partial products, meaning you break it up just like we do. My only suggestion with this one is just to make sure you know, okay, hey, I'm multiplying a fraction or a decimal. Oh, okay, now I'm multiplying a whole number. I got to be to the left of the decimal place. That's the one piece that will hurt you. If you're using the distributive property, I highly suggest you just use scratch paper, no big deal. Whiteboard, not a problem. If you're going to use the partial products, I would suggest you go over to the bin and you get yourself some graph paper. That way it keeps you in line. You can keep those decimal points flowing down. Either way today, I want you to practice these thoroughly. Okay? Either one's okay with me. Choose the one that you like best or bounce back and forth, either one. But I do want you to try both ways and then find the one that works best for you, because really you don't need to know a million ways, but you got to have one really good way to solve decimals times whole numbers. Okay? So we're going to turn the page here. All right. So there's another problem here. All right. And I'm going to let you work through this. And once you get down to these things, it's up to you how you want to do it, okay? So you can use the distributive property, you can do whatever you want to do there, but it says place the decimal point in the product. So you're going to have to rework these problems down here. And then you're going to have to tell me where the decimal goes. If you notice, there's no decimal places in any of these numbers, okay? Which is not right, because here's a decimal, and here's a decimal, right? So you're going to have to rework these problems, and you need to tell me where the decimal place needs to go. All right, so you need to almost fix their error is kind of what it's looking at. All right, I suggest you work through this problem. I'll read it before we leave the day, and then I want you guys to work through it. They use the, let's see, they write the decimal factor whole number, so they're using the new trick that I use. Okay, so let's cover that really quick. Okay, so having a thickness of 1 in 35 millimeters, the dime is the thinnest coin produced by the United States Mint. If you stacked 8 dimes, what would be the total thickness of the stack? Okay, so this is the trick that adults use. That if you go home when homework tonight, they're going to know this trick. All right, so it says write the decimal factor as a whole number. So instead of 1 in 35 hundredths, they're basically just telling you to ignore the decimal. So 1 in 35 hundredths turns into 135 times 8. Okay? And 135 times 8, after you do all the math, boom, you get 1,080. Okay? Now they say, okay, now if you multiply this by 100, you need to multiply it back by 100th. But I got a quicker rule for you. All right? As long as you know that, hey, I had to move this decimal place over 2 place values, 2 zeros, boom, boom, I had to multiply by 100. To send it back, I have to multiply it by 100th. Boom, boom, right? As long as you know the process, we're good. Here's the trick, okay? After you pretend that there's no decimal point here and you do 135 times 8, you get 1,080. The trick to put the decimal back in the correct place is you have how many, in the total mathematical problem, how many numbers are to the right of the decimal? Okay, well, I see 1 and I see 2. This is a whole number, so there's nothing over here. So I only see 2 decimal places. Okay, keep that in mind because when after we solve this, so you get 1080. Okay, I'm going to go to my board here. So we get 1080. Okay, and we have 2 place values to the right of the decimal, the 3 and the 5. That tells us how many hops we need to hop at the end of our problem. So we know we got 1 hop, 2 hop. There it is. Okay, if there was only 1 number, we'd hop once. If there was 2 numbers, we'd hop 2. If there was 3 or 4, we'd hop that many hops. Okay, so our answer is 10 and 80 thousandths or 10 and 8 hundredths. Okay, questions on that? The trick there is just remembering how many decimals are to the right and then hopping from right to left that many hops. Okay, so there's 3 different strategies you can use. This is my strategy. Okay, I use the patterns. That's why we teach you the patterns. Oh, okay. So if to get this to be a whole number, I have to multiply by 1,000. To get it back, I have to multiply it by, or I'm sorry, to get it to a whole number, I have to multiply it 2 hops. That's 100. To get it back, 2 hops. So after I get my answer of 1,080, I got to multiply the 100th to send it back where it came from. So 1, 2, 2 hops, 2 zeros. Okay, that's what we use, and that's what it's just quick, it's fast, and once you learn it, and it's done, it's easy. Okay, so you're going to explain how you know the product of 8 times 1 3/5 is greater than 8. Think about that. Whole number and a decimal. What we talked about yesterday. If it's less than a decimal, it's going to be less than 8. But what's different than today? That is a whole number and a decimal. Okay. Then you can say, what if you multiplied 35 hundredths by 8? Would the product be less than or greater than 8? Explain. That's what we talked about yesterday. Then come down here, make your corrections, rework your problem, or remember the rule I just taught you. How many numbers are to the right of the decimal? How many hops? Okay. Once you finish this page, which shouldn't take you too long, move on to your independent page. Okay. See how far you can get. All right. Through this page. If you finish the page, just keep going. Do not do the homework page. Okay. Do not do the homework page. Stop on this page if you finish. Okay. Raise your hand if you have extra questions. Okay. I'll come by and I'll help you if you need it. All right. And then the last 10 minutes of class, we're going to stop and we're going to do the exit ticket. Okay. All right. I hope you enjoyed today's lesson. Again, if you need me, raise your hand. I'll be moving around the room. Feel free to get a whiteboard. Feel free to move around the room, get some space going. I have hundreds charts. I have graph paper, whatever you need to be successful today. Okay? All right. Good luck, and get to work.